the case of water in a tank rotating about its axis, the velocity varies directly with the radius. Obviously, lines or sticks, either tangential or normal to the streamlines, will rotate just as they would in the vortex filaments seen before. However, if the velocity varies inversely with the radius, as it tends to do in the field of flow surrounding a vortex filament, whether above a drain or in a tornado, a line or stick in the tangential direction will tend to rotate in the opposite sense from one in the normal, but at the same rate. Two perpendicular sticks fastened together will then not rotate at all. Such flow is called irrotational. The central filament itself, of course, is highly rotational. Flow in concentric circles is not the only kind that is sometimes highly rotational and sometimes almost irrotational. Uniform flow between parallel walls is usually rotational. On the contrary, either non-uniform or unsteady flow that is rapidly accelerated is very nearly irrotational. Now, the important part about irrotational flow is that the flow pattern can be approximated graphically or mathematically by the construction of a network of streamlines and normal lines, which are so spaced that they divide each other locally into equal parts. As may be shown mathematically, for any shape of the solid boundaries relative to which the fluid moves, there is only one correct flow net. And after a little practice, with plentiful use of the eraser, its first approximation can be very rapidly sketched. It is thus possible to have rotational flow without deformation, as in a tank of any liquid turning on its axis at constant speed. Conversely, the motion of a viscous liquid between cylinders, having tangential velocities that are inversely proportional to their radii, is, despite its deformation, completely irrotational. Flow between closely spaced parallel boundaries will be rotational in any plane perpendicular to the boundary, but essentially irrotational in the plane of motion. This gives rise to the Healy-Shaw method of showing patterns of irrotational flow through use, paradoxically, of a viscous fluid as approximated by sprinkling dye crystals over the thin sheet of free surface flow on this water table. By and large, however, the motion of a viscous fluid is likely to be rotational in all planes.